Alright guys, if you've stuck with me through all these videos on the ultrasonic level sensor, I really appreciate it. You guys are a patient lot. The next thing we're going to do is we're going to finally put in our proportional integral and derivative. So this is where things should get cool. So now we've got the 4 milliamps coming in, we've got our trend recorder, we've got our level, percentage, and voltage that we set up for our analog inputs. The next thing we need to do is do our PID. So I want you to go over to Controller, Tuning Constants, click on that guy, and then we're going to take away our derivative and change our proportional. I'm going to start off with a proportional band of 200%. I'm going to take away the integral and I'm going to leave the derivative at 0. Okay, and keep the derivative off on error. So we're going to start off with 200% proportional band. So what is a little bit harder to understand is that the proportional band is the opposite of the gain. So if you have a large proportional band, in this case I have 200% proportional band, then my gain is really low, meaning that it's not going to react very fast. It's going to be really slow acting. I don't have any integral, so if I have an offset, there's nothing to take care of that. Right? If there's a difference between my set point and where my control variable is, I don't have any integral to take care of that. And the derivative, there's nothing to give a boost or a brake to the system either. So we should find that this is, not bad, gives us pretty good control, but it's a little bit slow acting. Okay, so we're going to close this up. Those values stay in. And now you can see that I have my set point at 50%. And if I want to set my set point, I can go here and then set it. So my set point's at 50%. I'm going to unpause my trend recorder here. But you can see that my control variable is way down there at 0. So I've got to actually bring the level up to a 50% set point, or to match with my set point. If I start at 0 and then try to have the computer take over, it's too much. I need to set up my actual level at 50%, matching with my set point, and then it'll be a lot easier for my computer to take over and have my set point and my control variable matching with my PID settings.
Alright guys, so what we need to do is we need to increase the level in the tank. Right now we're at 10 centimeters. So 10 centimeters from the previous videos we saw corresponded to 1 volt on our 1 to 5 volt signal. That was coming from our 4 to 20 milliamps being pumped through a 250 ohm resistor. So that 1 volt corresponds to our 4 milliamps there. But we've got our set point here. Let me just draw. There's our set point right there at 50%. So I can't put this into automatic mode yet because my set point is at 50 and my control variable is at 0. Okay, you can see here that my control variable is way down here and my set point's here. If I tried to have the computer take over at this point, that's just madness. You need to allow the computer to just do some small changes, right? But going from 0 to 50 is a bit too much. So let's increase the level in the tank. So what we're going to do is we're going to, and you'll have to excuse the camera work here, guys, but for me to go back and forth and dub everything, it'll take too long. So we're going to start up the pump. Okay, then we're going to increase the output to the pump. Okay, nothing crazy, but like 30-35%. Okay, so you can see 30-35%. And now what I need to do is I need to open up my ball valve. So I believe this guy is my fill. And I'm going to fill the level in the tank up to my 30 centimeters and then stop it at 30 centimeters. Gorgeous, okay? So that's 30 centimeters there. That's my 50% range. 50% should be 3 volts, so we'll just double check. Gorgeous, I'm basically at 3 volts. If I look at my current, so let's go back here and we'll look at our current here. And we got 12 milliamps as our 50%. Beautiful. Okay, let's take a look at the trend recorder, guys, because this is going to tell us everything now. So now my set point and my control variable are at the same value, right, or very, very close. And now what I want to do is I want to set up my proportional, integral, and derivative values. So I'm going to go to controller. I'm going to go to tuning constants. And now I'm going to be able to change my proportional, my integral, and my derivative. First thing I want to do is I want to get rid of the derivative on error. Next thing I want to do is I want to change the proportional. And with this guy, I'm going to change this to 200%. So I'm changing the proportional band. Understand that the proportional band is the opposite of the proportional gain. So by increasing the band, I'm decreasing the gain. So this is going to be a really slow acting circuit now. I have no integral, so if I have any offset, any difference between my set point and my control variable, there's no integral to take care of that over time, and there's no derivative to give me a boost or a break to the system. Just proportional. And right now with the band really high, my gain is going to be really low. Okay, so we'll close this guy up. And at this point, I'm ready to rock and roll. I can let the computer take over. So I'm going to put this into automatic mode. Nothing's changing because I still have those ball valves closed. So trusting the computer to take over, we're going to now open up our drain and our fill valves, and then we should see it settle in at 30 centimeters, right? What the heck's going on? This is supposed to be better control, and yet the level just seems to keep climbing. I asked it to be at 50%. The computer's supposed to be smarter than I am, and it just keeps climbing. It's climbing up to 38 centimeters now. Well, that sucks. Why did I buy this PID controller? Well, maybe it's not the computer, maybe it's the operator, right? So remember that we have proportional. It's really slow acting, and there's a massive offset now. We got to be at 30 centimeters, and we're at 38. So let's change our proportional band. Again, sorry for the camera work here, guys, but it's easier just to go back and forth. So we're going to go here to controller. We're going to go to the tuning constants. Now, there are lots of ways to change PIDs. You can get your PhD and PIDs. Unfortunately, I'm still in grade school when it comes to PIDs, so I'm just going to go with the simple thing. I'm going to reduce my band by 50%, which increases my gain by 2. So I've doubled my gain, so it should be reacting a little bit faster now. Okay, as soon as I do that, look at what happens on my trend recorder. All of a sudden I'm getting closer and closer to my set point, and we should see now that the level in the tank has dropped. So we were at 38, beautiful, we're down to 34 and a half. We still have that offset, that difference between where we're supposed to be and where we actually are. Now we could introduce some integral, but we want to see what happens with this proportional on its own. Okay, so that's not doing it for us yet. So let's do the same thing. Let's drop our proportional down by 50% again. Going to go to tuning constants. We're keeping our set point the same. I'm going to drop this bad boy down from 100 down to now 50. And we should find that on the trend recorder, it drops right away. There we go. Very nice. So as soon as I increase the proportional gain, then it gets closer and closer to that level. It says it's at 32 centimeters. Let's go see if that's actually right. Okay. Yeah, that's not bad. Out in the field, I am at 32 and a half now. I'm still trying to get to 30 centimeters though. I still have this offset that's there. Again, I could put some integral in, but let's see what happens if we put some more proportional in. Can we get closer to that value? Because the proportional does the bulk of the work, right? So let's see, we'll go to controller, tuning constants, and let's see. I find that like 25 is a little bit like too fast acting, so I'm going to go to 30. Again, no integral, no derivative. Close this guy up, and now we can see on our trend recorder that we're almost at our set point. It says it's at 31 centimeters there, but we still have that steady constant error, or that offset. Okay, 31 centimeters. Let's see if that's right. Okay, again, yeah, we're not bad. I mean 31.75. okay, so we need to close that gap. So now is the time to put in some integral, but let's see if a step change will do it for us. Let's go up to 40 centimeters, 40 centimeters being 75% of our range, and see how this guy reacts. So in order to do a step change now, I'm going to go to controller, I'm going to go to set point, and now I'm going to change my set point to 75, which corresponds to 40 centimeters. As soon as I do this, the pump is going to go crazy. There we go. So now you can see that we have that increase in level there. A bit of an overshoot there. Is it going to settle down? No, it looks like I still have that offset there. So at this point, it looks like it's really fast reacting. Like, look at here, really fast reacting, right? The level is at 41, but I need to drop that down to 40 centimeters. So now's the time to bring in some integral. Integral looks at the longer something's screwed up, then the more it's going to provide a boost to that proportional signal. So let's go to controller. Let's go to tuning constants. And now the proportional was just a percentage. If you take a look at the integral is actually a time. It says minutes per repeat here. So I'm going to do that, and I'm going to say, all right, every half minute, I want you to take a sample and then give a little boost to the proportional. So let's take a look. Every 30 seconds, this guy, there's the sample right there, and it just dropped the level down closer to 40 centimeters. Then we'll wait for another 30 seconds. When it takes another sample, it'll give a boost to the proportional. Ah, yes. There we go. So the longer and longer that the integral is part of the circuit, the closer and closer it gets to my set point. That offset is being slowly decreased by the integral. Let's look at one more sample here. It's like watching paint dry. Looks like that's the best it's going to get. Oh, there's a little sample there. It's fighting to try and keep that that level. I can't focus that close. There we go. Beautiful. So we should be at 40 centimeters. Let's see if we're actually at that value out in the field. So let's see. Now we're off by a touch. Remember before we had that issue before with that voltage coming in? Let me take out these other jumpers here and see if that value actually... That's not bad. That's pretty close to 40 centimeters. Beautiful. So if you're wondering what I just did, I just took out the other two jumpers on my I/O interface, because before they were screwing up my my voltage values. They were reducing them. I had a number of different jumpers going to 2 and 3, but I'm going to get rid of those guys for now. Okay, beautiful. Okay, so the integral is bringing us closer and closer to 40 centimeters. Let's do a step change now down to 50% and see how this reacts. Okay, so again, I could be in the control room way far away from this tank and controlling everything. So I'm not going to change my set point now. Going to 50% now. Close that. Gravity's just dropping that value out. Hopefully we don't have an overshoot. Ooh, that's gorgeous. Okay. It says I'm right at 30 centimeters. My calibration seems to be off by a touch. But based on this guy, it says it's right at 30 centimeters. Let's see. That's pretty good. It's like 33 or something like that, right? So I could finesse my signal coming in. Again, I'm not using that current signal, I'm using that 1 to 5 volt. So I'm wondering, with all those changes from the 4 to 20 to the 1 to 5 with that resistor tolerance and everything, whether that's accounting for that 3 millimeter change. That's pretty good though. Let's go down to 20 and see how it works. So let's see, 20 would be a, let's see, that would be 25%, right? Come on, buddy. Okay, so we'll drop this guy down to 20 centimeters. You can see that as it gets close to that value, the pump turns on. No overshoot whatsoever. And I should be at 20 centimeters now. Nice, 20 centimeters. Again, we're like 3 millimeters up, but this is gorgeous. Okay, so let's go from 20 all the way to 40 and see with a large step change in the opposite direction whether the proportional and the integral can do it for us. Okay, so we're going to go to 75% now, so we're going to change our set point. Going to change that guy to 75. Pump is screaming. Let's see if we get an overshoot going up now. You see that the proportional is backing off now. Little touch of an overshoot there. It's not bad. That's pretty good. Integral should kick in and then drop it down a touch. That's not bad. It says it's at 40 centimeters. That was really fast acting. And let's see if it's actually at 40 centimeters out in the field. There's that integral coming in. Beautiful. So again, we're off by a touch there, right? With that 3 or 4 millimeters there. But for the lab, this is mint. Okay, so we're getting really good control over this guy. We could try and get it to go a little bit better. Maybe we'll try just trying that integral, right? Just to see if that integral will give us that last change there. Tuning constants. Let's reduce this to every quarter minute to take a sample. Looks good. I'm right on where my set point is. I'm going to change my set point back to 50 one more time. Gravity acts to drop the level in the tank, and as it gets closer to 30, comes back in. Ooh, that's nice. Look at that. 30 centimeters. Beautiful. And this is like, try and control the pump and get it to come in exactly when the level is dropping and have it sit right at 30 centimeters. There's no way that you can do that on your own. Gorgeous control. Okay, one last step. Let's do up to 40 one more time. We'll see how it reacts, and we'll screw everything up by putting in some derivative. Okay, so we're going to go to controller, tuning, no, not tuning constants, donkey. Close that guy up. We're going to go to controller, set point. We're going to go to 75 one more time. Now, there's no way out in the field you're going to be doing 25% step changes, right? PIDs are basically set up so you can do like a 1 or 2% step change, and it'll see how fast it reacts, provide all the data, and essentially the algorithm will give you exactly what your proportional, integral, and derivative is going to be. There's no way that, like, if you're using a massive like pipe bender or something, you're not going to change your set point by 25%. You're going to do small step changes and see how it reacts. We're going up to 40. We now have the proportional, the integral. We still have, interesting, we have more of an overshoot now. So if that's all right for your parameters, then that's cool. Really fast reacting. Integral should bring us in. We're supposed to be at 40 centimeters. Let's take a look at where we are. And again, yeah, we're still off by that touch. I loved it at 50, but I'm not loving this at 44. That's all right. That's pretty good control for the lab. Okay, so that is just with proportional and with integral. Okay, remember that the proportional does the bulk of the work, and the integral just closes any offset that we have. Okay, now let's put in some derivative, and I'll show you how the derivative works. Now, the integral is another name for that guy is reset. Like, you're resetting the set point. And in trying to get to that set point, it actually gets to that new set point. It gets to your original one that you were striving for. Derivative is another name for that is rate. So it's looking at the rate of change. So for this one, we got good control with proportional integral. I wouldn't put in any derivative, but let's put it in just in case. So see how it reacts. So we'll just say like every minute, let's take a sample. Holy. Okay, so remember the derivative looks at the rate of change. And any like noise or anything like that is going to be affected. Look at that. The pump is turning on and turning off and turning on and turning off. And thank goodness I have that overfill. I'm going to stop this and close my ball valves because that is crazy. So you can see the pump. The pump is turning on and turning off. Turning on and turning off. We're going to burn that motor out over time. Right? So we have this derivative that was supposed to give us some better control, but look at these crazy reactions here with the derivative now. So, and it wasn't like I gave it like a small time frame. I said I'd just every minute take a sample. All right, so settle down there, buddy. Let's go and take away that derivative. Let's take that to, oh, what's going on? Okay. Take away the derivative. Yes. Yes. Now I trust that it's actually going to work. So I'm going to open up my ball valve and we'll see how fast this guy goes back to my set point. Now my set point was what? It was supposed to be 75%, right? So because I screwed everything up, it's taken a while to get back there. But it should slowly go up to 40 there. Slowly, slowly, slowly. Okay, by putting on the derivative, it just screws everything up. You can see that integral is slowly bringing it back to my set point at 40 centimeters or 75. Awesome. There we go. Nice tight control. Okay, last thing I'm going to do is I'm going to bypass some of the water going to the tank. So I'm going to open up a ball valve and I'm going to take away some of the water going to the tank. And you can see there that the level drops, but the pump now starts to increase. And even though I have a bypass valve on now, and a lot of the water is going back to my pump, it's still keeping good tight control over the level. Okay, I'll close that valve in and it will have a small overshoot and then should drop down to the 40 centimeters again over time. So you can see here that there was my my valve that was opened, right? And now it's slowly bringing it back to the level that it was supposed to be at. All right, guys, hopefully that helps with the proportional integral and derivative. Wow, you guys have been patient. You set up the ultrasonic sensor. We got it calibrated. We looked at the current coming out. We took the current 4 to 20. We changed it to a 1 to 5 volt signal. Then we sent it into this program. We set up all of our parameters in our trend recorder. And then we put in our proportional integral and derivative. Right on. Okay, let's do just for a last step. Let's go for here. We'll go set point. We'll do our set point back to 50. And we'll see how it reacts one more time. Okay, so 50% should be 30. Ooh, that's gorgeous. Look at that. All right, guys, thanks for your patience. Hopefully now PIDs are a little bit more fun.